From the backwoods of Virginia, this is Daniel Markham with the danielbmarkham.locals.com channel. We're going to do an interview today. I'm really excited about this because I just ran into this person on the internet in the past week who's doing this really, really cool stuff. And it's F#, it's functional, it's functions as a service, it's all kinds of, it's OCAML, good stuff coming up. Paul, nice to meet you.
Nice to meet you too.
How do you pronounce your last name? Is it Biggar?
Biggar, yeah.
So Paul, I guess before we dive into the tech stuff, can you tell me a little bit about yourself? Are you on the East Coast, or you?
Yeah, so I'm in New York City. I just moved here before the pandemic. Originally, I'm Irish. I did my PhD in Dublin. Did a PhD on static analysis of PHP actually, compilers, execution, all that sort of thing. Then came to the US. Did Y Combinator, terrible startup, didn't go anywhere. After that, I was an engineer at Mozilla on the Firefox JavaScript engine. After that, I started CircleCI, and I ran CircleCI for about 4 years, and then took a break, and I started Dark.
Oh, cool. So for the folks who are coming at my regular readers who have read the books that I've written, the end of the second section of the second book, I start talking about in the second section how to write good code, how to manage cognitive complexity, code cognitive load, all kinds of stuff related to sort of making it easier on you, the programmer, to code. And when we got to the end, my point was, gee, dudes, if we're writing this all up as pure functions, and .NET lets us put these functions anywhere, actually, whatever we compile into can also act like a pure function. And then we really, the units we compile in is sort of arbitrary. We can compile it to a monolith, we can compile the web. And then you start thinking about, well, gee, if we can compile anywhere we want to, why not just make a super compiler that takes our code and puts it everywhere and manages resource management as we do on the desktop, only on the entire internet. So that's kind of where I got here. I didn't really take the super compiler concept any further than just sort of talking about what it meant and what it was. And then, dang, I ran to you last week. You wrote While We're Leaving OCAML.
Mm-hmm.
And I got started reading the OCAML books because there were no F# books at the time. And I moved to F#. And then, the next essay was, we're moving to F#. So I'm like, I got to talk to this guy. Mm-hmm. So you started off, you did work for Mozilla. You ended up, you did, I guess, a computer science degree. Mm-hmm. You ended up in New York City, and you had a problem, I guess. You did the Y Combinator thing. What was your problem that led you to Dark?
So the origins of Dark is just like how hard it is to code. In particular, you're trying to build backend services, and you're just dealing with so much shit. I came to it from a bunch of different perspectives, and I think that's the summary of all of them. But I look at beginners trying to build backend services. I look at my own side projects where I end up spending 3 hours setting up infrastructure and then being bored and giving up on it. And I looked at what it was like running a company where every new service or every new workflow that we wanted to bring on that wasn't our core competency, we had to buy a third-party service because it was actually too hard just to build any tooling ourselves and support that additional tooling. And I felt that all of those were the same problem. This problem that backends are too hard to build, code is too hard to do, and that it's because fundamentally we have stacked so much shit on top of other shit, and that it is we're coding at the wrong level. And so if there was a language where you coded sort of above the cloud, it sort of took a cloud as its VM, sort of in the way that Python builds a VM on top of a single computer. Where could we go with that, and what just stuff could we just remove from the coding process?
So there's a demo video for you guys. You should probably watch this after the interview. It's really neat. It looks as if you're using the web browser to sort of create functions, and you attribute those functions by their endpoints and whether they're events or whatever. That's awesome. I guess you came up with the idea of using the browsers in IDE because why do we need text files on our local computers anymore, right?
Yeah, so text files on our computers is one of the things that we're that I think causes this complexity. Um, the, uh, the thing that we did at the start was we wrote up all the things that we felt were accidental complexity versus essential complexity. Um, and
Ah,
parsers is one of them. So a parser giving you parse errors like those, that's sort of a weird thing. It's a vestige of the fact that we write code in text editors and then we send them to each other via diffs, or maybe the diffs are in Git, but even Git is a better version of this old way of doing things. Um, and so it's like, all right, I think removing a parser is going to be one thing, and we're going to use a structured editor instead. And I've been using paredit to write Clojure, and I thought that was a wonderful editing experience. And I really felt that writing live was a key thing. So we wanted to remove the CI/CD process from it as well. I wanted to make that safe, and so that meant that you had to write code live in production, and that wasn't going to happen by r-syncing something into a Docker container and all that shit. It had to happen by this very tight loop of you write something in our editor, we take that that AST diff essentially and put that into a database, and then everything is like automatically pulled from it. So it was really building that editor isn't so much, we don't want there to be text files, although it is that a little bit, but it's the idea that everything has to be holistic in order to be able to remove all of this shit.
it's
By everything
fascinating.
holistic, I mean our editor, our programming language, and our infrastructure. It has to be like super integrated, and that's what lets us remove all the complexity.
Yeah, that's well, it's interesting that you kind of hit some deeper topics as we went along. I think the key thing was that you guys sat down and talked about all the different complexities, sort of accidental or necessary, and from there you modeled out functions, and the functions could be actually forced to parse. So therefore, you need no parser. It's I think I would go at the problem a different way, but that's a subject for a different day. What made you choose OCAML to write this in?
So I liked some types basically, and I had thought previous company Circle CI was written in Clojure. Clojure is pretty great, but it wasn't statically typed, and I really felt like the whole company felt the pain of not having static types. And most of the classic languages that do static typing, Java, C++, there's a lot of accidental complexity there. I didn't want to be there.
Oh my
Looked at
God.
Haskell, quite a lot of its own shit going on there. I didn't feel that was the right thing. And so I'd read about OCaml, and it's like, a lot of my problems with Haskell are this lazy execution and the way that it's a language built around lazy execution, and OCaml is like, well, it's statically typed. It has eager execution. You can just write statements that do things and that have side effects. And I thought that's actually really what I want. And that was what we were designing Dark to be as well. So Dark is a language that has roughly the same semantics as an ML, as OCaml, as Elm, as F sharp, and it made sense to write it in OCaml. The other thing that made a lot of sense was performance was important. And performance isn't important that we wanted to, in the sense that we wanted to eke out every last bit of CPU. It was more that I wanted to write an interpreter to be Dark because that was just so much easier to write than a compiler. And it would be so much better for the fast turnaround for getting that code deployed. And so it had to be a language that was whose compiler, runtime, etc., was fast enough that we could get away with writing an interpreter. So it really had to be a compiled ahead of time language. It kind of cut out Clojure and things like Python.
I love the REPL idea as far as just running the REPL on the web. That is really, really cool. So when you move to OCaml,
Mhm.
I'm working two tracks. I'm listening to you. I'm working the track of how you designed it, how you worked on it, and actually how it works itself.
Mhm.
When you moved to OCaml, you mentioned in some of the stuff I read, you did the first prototype in 2 weeks in Python.
Yeah.
So you moved to OCaml. What was your strategy as far as functions versus classes in OCaml? Did you start modularizing stuff up over there right away, or did you just start with functions and build your way out? Or
So the first version of Dark, um, basically I ported the Python stuff directly, and the Python stuff used classes and objects and that sort of thing. So I ported that pretty much directly into OCaml. Um, and it was a sort of a nodes and edges kind of design. It wasn't the language that you see today. It wasn't like an AST driven thing. Um, and a couple of months later, we God, it might have been longer than that. It might have been 6 months later that we actually abandoned that design. And because we abandoned that design at that point, we'd had 6 months of experience with OCaml at that point, and realized that really no one uses the classes part of OCaml. It's just not a well loved area. So we just stuck with the functional side of things after that.
one of the things you mentioned in the Leaving OCaml essay that I have up in the background is that you liked OCaml, but as you mentioned, there wasn't a lot of people there, and the library situation wasn't what you really kind of needed, I guess.
Yeah. I mean, I think that when you do startups, you have you have an opportunity to use um, off mainstream languages, and you really have to consider whether an off mainstream language works for you. And there wasn't really a mainstream language that worked for us when we started. Um, and we expected that we wouldn't need such an ecosystem partially because we'd gotten away with it a little bit in Clojure. But I think I hadn't really understood why we got away with it in Clojure, which was that the Java stuff was there for when we really did need it. Um, and then we anticipated that we would have written a lot more of Dark in Dark by now, which hasn't really happened for various reasons. And that we'd be piggybacking off our own ecosystem that was growing. And so it would actually make sense to write the libraries ourselves because we would also be writing them for our community. So yeah, I think we never considered F# at the start. It was just like, oh, I should use OCaml. As sort of, steeped in the Unixy traditions,
Yes.
didn't really know the .NET ecosystem. And I think, where the .NET ecosystem is now versus 3 years ago when we wrote OCaml, I think it's or when we wrote Dark in OCaml, I think F# just really wasn't on my radar at all.
You, from reading your essay, I guess you sort of came at Microsoft perhaps a bit kicking and screaming due to their past reputation. How many people are on your team? I'm interested in this thing you talked about of the JVM giving you all this stuff in the past and not really realizing Clojure. Now you're over here. It seems as if you've had some accidental complexities sort of hit you guys as well. I was kind of
Yeah.
interested how many developers there were.
So Dark has gone up and down. Right now, it's just me. We had 8 people in July when we realized that the money we had wasn't going to make it. And for most of the life of the company, there was probably 2 developers, and we sort of grew to 8 over the maybe the previous year.
And were you guys working all virtually or together?
We were all working in the same office in San Francisco.
Okay.
They sort of have this belief that when you're inventing new things, that you have to be in the same place.
Yes.
But once we got Dark to a place where we were no longer inventing things, we actually went fully remote in February.
Fascinating. So you've been at this Dark, you mentioned February, what, a year and a half, 2 years?
So I started working on this 4 years ago, and we finished raising money a little over 3 years ago, and so we've been working full time on it for 3 years now.
What do you find the New York tech life to be like? There's a lot of, are you increasing your Lux surface area by kind of getting around, or, and COVID, I know kind of,
There's a pandemic. I'm barely leaving the house.
yeah.
I haven't gone to any meetups, haven't met up. I meet with friends for walks with masks and a distance and outdoors and that sort of thing, but really not going to any meetups.
Bummer. So I noticed you had, I guess we're kind of about halfway through, so we kind of did how we got here, how many years, funding, we're in New York, OCAML, some issues there, and you decided to make a move over to F Sharp. Just to reframe this in my own experience, I teach programmers, I code, I teach programmers in teams. And I went from, I guess, C Sharp, C++ to F Sharp when it came out because I just heard somehow or another that functional programming was the new coolness. And I picked up F Sharp back when it was in beta, and damn, it hurt my brain a lot to move over from object thinking to functional. It was just painful. But I tell you what I found was the F Sharp ecosystem, even back then, by being part of the Microsoft ecosystem, there were a lot of other OO guys that were making that kind of same shift at the same time. And so I stuck with F Sharp, not because I wouldn't have rather gone to Haskell or other things, but because it looked like a pretty cool teaching platform. A lot of folks out there that want to know more about it, and once I understood, I could help other people. What would have you made the decision? Have you done a lot of code here? Yeah, I know you already know functional programming. Have you found the environment difficult to switch over with, or?
Not really. I mean, it took a couple of days certainly to switch things over. I don't necessarily like some of the things that maybe don't matter all that much. So like I think that the what is it called? Fantomas is the formatter. I think it makes some poor choices, and it's like you learn to live with that sort of shit. I think the tooling's pretty good. I use VS Code, so I've got lots of lenses and whatever they're called. I think overall it's pretty good. One of the things that you mentioned there about all these OO people coming over to F Sharp, I think that's really good, and I think that was something that was missing in OCAML. Like it's much easier to learn from people who who are writing the simple blog posts. It's like, oh yeah, no, here's how I wrote a web stack in F Sharp. In OCAML, there wasn't all that much of that. It was the kind of blog posts that people wrote were much more theoretical and deeper. And I found it a much bigger challenge to get into it. And I don't think I ever really became an expert in OCAML. And I sense that that's going to be a little bit easier over here. Just there's a lot more information on how it works.
Something I noticed when I moved over was the OCAML books did a lot of the recursive callbacks with the matching inside, where you finally get to the empty set, and they walk you through a lot of that stuff. And once you move to F Sharp, that stuff has already been rolled. Of course, I'm sure at OCAML, but it's all been rolled in. So you're using vectors most all the time. You lists of stuff, and you're just kind of cranking through them. It almost becomes like an SQL type situation.
Yeah, I mean the thing that really I love this first in Elm, but it's in OCAML and F Sharp, and now in Dark as well, is using pipelines. You take a thing, you do a thing to it, you do a thing to it. It's the same as object chaining in OO languages, but like it's a beautiful concept.
It's a very happy feeling. I don't know why. There's something I find a lot of joy in F Sharp that I didn't find in OO programming, because it feels like as you simplify the code, you're really coming to a better understanding of exactly what you need to do.
Yeah.
Whereas OO always felt like you were just describing what it was more and more, and what it did just sort of kind of went away into the wind.
Yeah, I really feel that immutability is one of the things that makes coding really easy to understand.
Yeah.
And that's kind of my problem with OO, that there's just no immutability. You're changing these objects. You don't know where the objects are changing. That's kind of the point of it. And the immutability in functional languages is just like, it just frees you to really understand what's happening.
It's so weird. You tell people that are new to functional programming, they're like, how could that be easier? Look at all these complex symbols or whatever, and you're like, but no, you're actually dealing with this smaller number of immutable things here.
Right. Nothing is ever happening somewhere else. It's happening here.
One of the things I found in my own coding that helped me become a better functional programmer, just for the old guys out there that are thinking of moving, when I moved to F#, I just started coding as if I were coding in objects. And so I wrote classes and I did the methods, and F# supports that. And then I started looking for functional smells, mutability, all the kind of pipeline things, all of those things I needed. And eventually, I don't know, within a couple of years, I just got rid of classes altogether. Now it's just all pipelining functions around that are immutable. But I say that to say this, one of the problems that made it so hard for me to move over was because I organized things in classes and these structs, and then I would pass this class or struct into a function, and oh my God, now I've got 50 things to remember while I'm inside the function that's all part of this struct I passed in. Mm-hmm. First, functional coding kind of forces you to simplify if you're actually going to manage the code, right?
Mm-hmm. Yeah.
So there's a forced simplification process, I think, in immutable functional programming, right?
Yeah, and I think that a lot of my own experience has come from OO. I learned OO first, Java, and then slowly found my way to like Python, which is also OO, and the scripting languages. And then finally found my way to functional programming. And, there's still this desire to I want to model a thing. Yes. I'm still trying to write modules as classes, and I think it's hard to avoid.
I finally, when I was writing a bunch of toy projects when I started, and I had this idea of writing, I guess sort of a Nook or a Kindle, a thing you carried around that just showed all the internet you used in plain text format. And so I wanted to prototype it in F#, and I wrote these classes with the async calls and all that. And it was just god awful, ugly. It was awful. It worked, but I realized at that point that I could write just as big a mess in functional programming as I could in OO. I had to rethink how I was structuring the solution in order not to make a mess.
Yeah, our front end, which is written in ReasonML, which is basically OCAML. We really made a mess out of that. Like the Elm, we used the Elm style, and we used the sort of Elm rules about sort of keeping everything global and not really putting things in components. And I think that was a mistake. And we now have just state sort of everywhere, and it's sort of what you get when you have 6 engineers working on a thing and there's no real direction in it either. It's easy to write bad code in functional languages too.
Yeah, I started off with when I got into C++, I saw these terrible messes in C++, and I tell people that I love C++. I would never code again in it, but I love it because it taught me that it was my responsibility to scope down the types of things I would use when I was solving the problem. And that was, whatever I was getting, you're talking about the Elm thing, whatever pattern you use, you have to have a universal pattern. Everybody's going to sort of use that one person can't simplify this way, another person simplify the other way. Then you got a big mess that way, right?
Mm-hmm. Yeah, goes either way.
Yeah, because you have to be able to reason about it. One thing I do like about OO code is that if it's well done, you can get into it within an hour or two, be able to reason about whatever's going on, no matter how big the code base is. That's nice. So let's go back to F#. You've written some stuff in F#. You're going to use F#, I guess, on the back end and Elm type on the front end.
Yeah. So to validate that was moving to F#. Actually, I was validating should we move to Rust, because I thought that was where we were going to end up. And so I wrote the core of the Dark interpreter in async, which was the intent of what I wanted to try. and I wrote that in Rust, and I wrote it in F Sharp, and I actually wasn't able to make it work in Rust. I was able to write the interpreter, but when it came time to turn it into async, the complexities of Rust related to async are just it just blows up the complexity another level up for an already complex language. But F Sharp was like pretty straightforward to write. It was just the same as OCaml. Wrote the code worked great.
Part of what the F Sharp team has done, I think, is they've done a really excellent job of wrapping the sort of .NET IL in a better syntax. For instance, they're moving. You can get a null when you call a .NET function, and nulls are something you really don't want to mess around with that much. So what I've used in the past, what we all used was options. You get an option back, then you evaluate the option. But I think they're actually moving from that to more of a type that has the null built in to make it even more type safe. So they're using a lot of lexical solutions where you just kind of learn the lexical pattern and the problem goes away and you don't have to kind of worry about it anymore. I think that they've, I guess, gamified F Sharp much better than OCaml or Rust or some of these other languages.
I think F Sharp is basically a clone of OCaml. And I think that they had the time to say, actually, we're just going to remove this bad feature of OCaml. And I think it would be good if OCaml did that itself. Sort of like abandoned a couple of things and changed how certain concepts worked. Like the files in top to bottom. I guess F Sharp has that as well. I think that's a bad idea.
Yeah, that took a little getting used to. That you had to actually it was back to the old days of C where you had to compilation order seemed to matter, and then you got name spacing, and it wasn't too bad coming from O, but really things should sort of stand alone. Right?
Yeah. Well, I'm not so sure that things like cyclic modules aren't necessarily just fine. I think maybe it enforces. People say it enforces good practices, but like. My kind of thought to that is like, fuck you. I want to write what I want to write, and if I need a cyclic reference to test something out, then I'll do it, and maybe I'll make it nice later.
Oh yeah, I used to have C++ header files that was like, if include count equals 17. I was like, yeah, okay, when they get so deep, okay, fine, but you just keep going for a while, right?
Good time.
Okay, so back to F Sharp. You guys, you've got this back end you're redoing in F Sharp. That's gonna. Where does that go? Where are you running this at? I know you've got a browser front end. Are you pushing it all to JavaScript and running it all on the client, or?
So it runs in a variety of different ways. So so we have this editor. You write code in the editor, and you see live values, what we call trace-driven development. So whenever you write code, you immediately see the result of that code off to the side of the editor. And in particular, when you make a request to our infrastructure, we save that entire trace and we ship that down to your editor. So you can see actual requests that you've made, and even in some cases where there's where there is no handler for it, we'll show you a 404 and you can press a button and then you get a handler that fits the shape of the request that you just made. So it's kind of lovely. So if you imagine what the infrastructure is like to support that, well, we need a bunch of servers, and that's just Kubernetes. Kubernetes is running a natively compiled, currently OCaml. It'll be a natively compiled F Sharp. It's got some Nginx in front of it. It's sitting in Google Cloud. We're using a Postgres database. Pretty standard stuff. Then the editor is written in ReasonML, and it's talking to the server to pull down traces, and it can. Whenever you write code, the same interpreter that's running on the server is compiled to JavaScript, and it's also running in the client. So it's for the OCaml, we use JS of OCaml. For F Sharp, we're using Blazor. And so it has exactly the same semantics, does exactly the same thing. No need to like re-implement or do if-defs or anything like you'd do with Fable, or like in OCaml like you would do with ReasonML. So that was the reason that we chose that for that particular thing, even though the client itself is written in ReasonML. Yeah, and that's basically it. The same interpreter running on the server in the client, and then the usual support services that you'd expect around that.
And then as you write the code in the front end and it mirrors to the back end, you're persisting that in the back end in such a way that it can come back to the session again or scale it out. Or
every character you press is basically sent to the server immediately. I have this blog post, how Dark deploys in 50 milliseconds, that explains how and why. And then there's a bunch of safety built onto that, but all that is baked into the language and the editor.
So I guess your data calls, you're not caching data on the front end at all. You're going to have to, you're 50 millisecond. Here's the call I made. There's the 404. I hover there. Well, the 404 is a bad example, but I don't rerun the function How do you rerun the function? I guess is the question. You show results of each thing you type into REPL. Yeah. So when does that update?
So it's interesting because this was a thing that we sort of struggled with, and we struggled to understand at the start. When does the code actually run, and where does the code run? And it's actually it ended up being really straightforward. So you have this trace. The trace has already been executed once, and we have the results of all the functions and all the impure stuff. Anytime you change the code in the editor, the pure stuff automatically reruns, right? We have functions split into what's pure, what's impure, and so all the pure stuff just automatically runs. If it's impure, we give you a button, and it's we know the parameters to this. It hasn't been run. There's a little green button to indicate that it hasn't been run, and you click it, and it executes it on the server, updates the trace, and now you have the new thing. So what you end up doing in the 404 case is that you're actually building, you're building up the execution as you go. So typically when you're writing backend development, you have a curl call or a postman call or a client button or something. You click it, and then just keep redoing the thing every time. In Dark, you've received that thing once, and then you can just keep building off that as you go. Without having to re-execute the thing, so you don't have to go back to your editor, your client, or whatever it is, and you can take that request, and then a thing that we do quite commonly actually is we know what the request is, but we don't write the code until we actually need it. And it's oh, now we've come to that request has been made. Let me save this to the database. Let me save that actual call that we made a few minutes ago to the database now, and just continue.
So cool beans, you're not actually sort of remodeling the engine on the front end, because that could, as you said, that could get quite complex for no reason at all, really.
Mm-hmm. Yeah, I mean, the purity and the immutability enable this, and it makes it so that it's pretty straightforward to understand how the code is working.
So what's your library strategy? So we talked about moving to F# because of the library situation, having a lot of plug and play stuff, which is freaking awesome. So how do you bolt something to F# and have it show up on the front end? What's that journey look like?
So that's not actually the plan. The plan is to have a package manager in Dark. We have the start of one. We have functions for maybe 20 different vendors like Slack and that sort of thing on it. It's not good yet. I think there's still, as we started to expand it out, what we realized is we had cut so many corners in the language that a lot of these functions that we wanted to write just couldn't be done nicely. So we now need to go back and fill out a bunch of language before I'm really focusing on the on doing the package manager. But basically we expect to make it so easy to create a package. Basically you write the function, it'd be one button to add it versus the process with something like npm. I think we'll be able to rapidly grow our ecosystem, and basically everything is built on top of HTTP calls. You can't do stuff in Dark that isn't. Though we do have some functions in the standard library, like crypto stuff and that kind of thing, that would be implemented in F Sharp. So, if you're missing some sort of like elliptical curve thing, that's a thing where you make a pull request to the Dark repo and add it to the standard library that way. But most things we expect to go into the package manager.
Yeah, two things come to mind. Text file processing, I guess, is kind of trivial, but as long as you've got some endpoint, you're pulling whatever formatted text in from, I guess you're fine. And then the second thing is, I'm just spitballing because I like bullshitting. I wonder if there's some way you couldn't take a .NET library, since there's a standard calling mechanism there, and write some code to actually parse out the calling conventions, such that you could put in 3 or 4 examples and automate the whole kind of thing, where you just pick up a thing, provide 3 or 4 examples, and boom, you're in the
We
flow,
don't really want that, right? You're designing a language. You want your language to be, or you want the libraries for those languages to be idiomatic for your language.
Yes. Yeah.
I think there's lots of things. People keep suggesting, like, can you piggyback on npm? And it's like, I mean, I'm sure we could figure out some way to piggyback on npm. We could have made Dark, for Node rather than its own language, but like that's not what we're trying to do. We're trying to remove accidental complexity and piggybacking off an existing ecosystem that has a bunch of its own shit going on. That's not going to be good for us.
Yeah, I grok that. That makes sense to me. I for anybody that hasn't done a startup in the past, first thing that happens is nobody cares. Second thing happens, when they care, they always tell you what you did wrong. And then 3, if they finally care and get past telling you what you did wrong, then they tell you how awesome it is and how you should be doing it in the future.
Yeah.
And I know I'm doing that. You have a technologically fascinating project you're working on, so it sort of it engages my brain, and I hope that you're doing some developer outreach to sort of. That brings me to this: where is your audience? Are they nerds like me, or are you trying to reach for like business people, or what?
So it's not no code. It's very much for developers. It's not intended as a as something like Airtable or Zapier or something like that, even though it matches the capabilities of both quite a lot. The intent really is that one of the reasons that no code has become so successful is because the accidental complexity of coding is so high.
Yes.
So it's sort of like, if we had solved accidental complexity, we would never have needed to go down the no code route in the first place. And that's kind of what we're planning to do with it.
Cool.
I don't remember if that answered your question. What was your question again?
Where your target audience is, because
yeah,
I saw online, you kind of victim of your own success. It was looking so cool. Then the other nerds are like, well, shit, there's nothing here. You just kind of click in. There's no real programming going on, right? And that of course is the entire point. You want to make this as simple as possible.
Well, I think as well we've positioned Dark aspirationally. We've been telling people about what Dark is intended to be. And then they discover that it's not there yet. And we thought the beta flag would cover that, but I think we actually need to change how we position it entirely, and move away from Dark is the best way to build APIs, which is objectively not true today, into Dark is going to be the best way to build APIs once we've got these 17 things done, and show you the progress. We've got we've got 6 of them done. Right now, Dark is going to be good if you have a team of like 3 or less, and you're not trying to do any like video processing or whatever. I think that's how we need to talk about Dark a lot more. And in the past, we're like, Dark is 100 times better to build code. I was like, I was aspirational.
Have you? I'm just from a business standpoint. Have you thought about partnering with people like AWS or Azure or various cloud providers that you're plugging into? I guess already, right?
We don't want people to think about the cloud providers either. They are accidental complexity. So
I'm asking if you thought about it, right, as part of a partnership channel distribution system of, hey, you signed up for AWS. By the way, we also have this really cool Dark thing you can use if you don't want to code a lot.
Sure, I think that we are pre-product market fit. So thinking, that sounds like a lovely distribution channel. Maybe it's a good idea, maybe it's not. But right now, all of our focus is really on how do we make Dark into a really good experience for people, and then once we got that handled, there'll be plenty of places to go. You were asking about how are we reaching people? Basically, right now the way I'm reaching people is writing semi-controversial blog posts. They're not intended to be controversial. They're just like we are leaving OCAML. Here's why. We are coming to F#. I'm going to publish the trifecta this afternoon of why we didn't choose Rust. Milk this for as much as it's worth. But we're just writing about it and then trying to build a good product. And there's a lot more to be done there. I think it'll be over a year before we get the product market fit done.
So for people interested in the technical part, there is you got your repo up on Git. I guess people can come by and kind of see what you got.
Yeah, it's a mono repo. Everything's in there: the F#, the OCaml, the Rust, everything front end.
Cool. And you've also got your Twitter here. Interested the DarkLang Twitter. What else do we have? Nope. I think that's you've got a bunch of what is it? There's a video. There's a whole description of the philosophy of creation, right?
Yeah. And then the other thing is the blog right now. It's just every week I'm writing about what we're working on. Maybe not every week, but mostly. So there's a lot of information in the blog right now.
Well, as I said when we emailed one another, if anything I can do as far as the build process or the F# stuff, the F# community is really, really good about helping folks, which
wonderful,
is
yeah.
Awesome.
That's great. Thank you. Appreciate that.
Some of the other communities, not so much. So let me do my sign off, and I'll come back to you. Hang on.
All right.
Okay. So there's Paul with DarkLang. Hope you guys liked it. It was a really cool interview this week. I enjoyed it. As always, thanks for dropping by.